The performance of the R1T is going to be really quite spectacular. When you're developing a vehicle like that, you really have to apply the techniques and the technologies that are used in the racing industry. Not many OEMs have done this with a pickup truck on this scale. So it's this and these together. This is change 3, close air curtain.
The reason we're in clay right now testing is because we can do very quick changes on the fly.
Whatever this is, +10, take off that edge.
We're doing a quick adjustment, moving spoiler forward.
Full-scale testing really validates the computational simulations we do throughout the process. This is really important in electric vehicles because the efficiency is a direct correlation to the range that is possible. The reason we're able to be better on range than any other vehicle currently on the market is because we're better on aerodynamics.
You follow a good idea. This electric adventure vehicle,
it required new ideas. An electric vehicle that can be capable of traveling through harsher terrain, harsher environments. It involved iterating on all aspects to allow them to perform in the best way.
so how do you actually package all of these little cells together in the densest way possible so that it doesn't take up the whole cabin of the vehicle? We found really amazing ways to stack these cells up, connect them all together, and cool them as well. You need to reject quite a bit of heat if you're really going to be pushing your vehicle hard.
Everything that's in-house is in-house because it enabled the company to open up possibilities.
What we do first is we put all the chassis components, the battery, a lot of the thermal components, and the DC to DC chargers, a lot of different components. Once that's all built, then we start marrying the top hat, which another word for it is the body in white. But in order to do that, we have to put adhesive around the skateboard components. So we spent a lot of time preparing for it, making sure it fits, and then we lift the body up, put the bead of glue in, drop it down, bolt everything down, and we get it done pretty quick. It's used for various testing, vehicle dynamics, winter cold testing, suspension, chassis, electronics, software, autonomous. So we really bust our ass here, and I couldn't ask for a better crew.
You guys seen these up close? These look great. So these are the 20-inch all-terrains, and these are the 21-inch all-season. Low rolling resistance tires. Isn't that lovely? It's one of my favorite parts of the design. Awesome. This is a mix of engineers, manufacturing engineering, manufacturing ops, technicians, and we're all together working through building these cars. See a skateboard being assembled down there just a few minutes prior. I think you guys caught it earlier. Here, we assembled the battery underneath, the front and rear subframes, the drivetrain. You can see we're now laying in elements on the skateboard on top. We can walk down and take a look. And essentially what you see is manufacturing engineers, manufacturing ops, vehicle engineers, all working together, all these production parts coming together in a production representative process and a production representative orientation. The quality aspect of this is really important. So you see on all the part inspection booths we have around, what we're doing is we're making sure the parts coming in from suppliers are hitting our quality spec as well. It's really important that we do this collectively together. It looks so freaking cool, doesn't it? had to find different ways to work to make sure we continue to make progress. And teams are working hard, some from home, some from here. In many areas of the plant on 2 shifts as we really ramp up, bring up all the equipment in the facility. And over a very short period of time, essentially over a couple of months this fall, this 500,000 square foot room will be filled with our body shop, with robots, with fixtures, or conveyance, general assembly. There's a robot there. You guys want to see it? You can see it's in the same blue as what's going on the truck. So we like the color so much we decided to paint all of our robots that color.
So how many of these things are we gonna have here?
About 500. Cool, right? All the parts that come into the facility from suppliers, they come in largely in reusable dunnage. So containers that we can reuse. You know, we take the parts out and we ship the containers back. We're using ocean-based plastics to build them. And because we need thousands and thousands and thousands of pounds of plastic, you know, basically create like a vacuum cleaner for plastic in the ocean and put them into all of our containers. At their end of life, or if one's damaged, we can recycle it and use it in another container. So it's a really creative process by our packaging and logistics team. The product is the result of thousands of decisions across many different domains coming together. The decisions we're taking need to be really aligned, and if they're not, you can feel it as a customer, you can feel it in the product. I think everybody's really excited. Everybody wants to build a lot more of them.
I am so excited that they have license plate and they are on public roads. It's win number 1, the first car which is truly registered for Rivian.
We built this vehicle to get some early durability testing. It looks and feels somewhat like production, but is very early and somewhat prototypey. When you give it full throttle, it is like 4 seconds to 80.
In the production vehicle, we'll have more power and more torque to go even faster.
100 days of driving, 13 countries, 13,000 miles, wide open spaces. There are a bunch of wild horses. We just pulled up next to them, and it's a completely silent vehicle just sitting there idling, but there's no idle because you're an electric vehicle. One of the biggest challenges is charging. We built out a charging network throughout this route of South and Central America so that you can do this. We're really happy to be showing people that you can have an adventure in some of the most remote places imaginable.
Wow. This place is amazing.
The testing is going really well. We're getting lots of data to understand what's happening, specifically with the battery, suspension, and chassis components. How can we get the car to act and react better?
We've taken all of that data, we've put it into the vehicles that we're going to have out to customers next year.
I mean, we're all familiar with a lot of electric vehicles on the road today, but there is nothing sort of doing what this vehicle is embarking on right now.
We've got sand, we've got rock, these washboard roads, constant go, 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 go for, 90 plus miles.
It's all going to create a better product at the end of the day, because this is a pretty epic adventure, and if they can get through this, I think they'll get through pretty much anything.
I don't know, the fact that we're out here getting to do this and show the vehicles are capable, it's a pretty sweet day at the office.
We're in what it feels like the middle of nowhere in Arizona.
We drive it through rocks, we drive it in the dirt, we drive it through mud. We use it for development of our in-house inverters. These cars get really beaten up. So ensuring that we deliver torque, how we optimize the power delivery of the battery, how we optimize cooling of that battery.
There's a lot of technology kind of all working together, and then on top of that, we're taking it to extreme, rock crawling events, high speed off-road. So it really puts it through its paces. And then we're adding layers of software, slowly implementing new features. So the vehicle will start to recognize the terrain it's on or the mode it's in, and those will be happening kind of underneath the skin. It'll be doing it by itself, essentially.
And that's when things get more and more interesting for us in the software world, where since we have individual drives on all wheels, you will be able to estimate friction across sand dune or ice or snow. This vehicle can do quite a lot of things.
This vehicle is designed and engineered by people who live that outdoor adventurous lifestyle. So I want to make sure that the product that we deliver to the people does exactly what we say it does. You typically will make a bunch of compromises to do one thing really well. It'll be really good off-road, but then on-road it's kind of soft. Whereas our vehicle, it has such a broad spectrum of performance. You essentially look at, what makes it good on-road, what makes it good off-road, how do we minimize the number of compromises that allow both? And that's kind of how we arrived at the solution that we did. That's why we have 4 independent motors, so that we can optimize grip off-road, but then also optimize the handling balance on-road. Air suspension, it changes heights. So you can go to a low aero mode for efficiency. You can go to an off-road mode where it's lifted up and gives you extra ground clearance, and it's extremely capable and very confidence-inspiring.
We're doing the Davis Dam cycle, and so this is where a lot of trucking companies come to prove out their towing capacity. What we're really looking for is maintain cabin temperature and then maintaining the powertrain cooling as well. And what we're trying to get is a limitation in neither.
Did it on Davis Dam with 11,000 pounds, so it was pretty good to see that, like thermal validations happening. We were passing all the criteria, so it felt pretty great. All those 36 hours is definitely all worth it.
Today we're at Mount Charleston doing some uphill testing in extreme heat and testing the thermal system. So today's goal is for completely hands-off. It's like a customer would be in this vehicle and they could drive it up and have no intervention. Realistically, if we have customers that own our vehicles that live out here or want to drive around here and see the scenery, we need to build a car for them too. So we're really testing the car so that our end users can use the truck the way they want them.
Like, it's 99 degrees Fahrenheit and we're already at 4,000 feet. This is a fairly extreme test. It's a step up in difficulty from what we were doing in Davis Dam.
Targeting 50 mph.
Copy that. We're at 35 right now and increasing speed.
Cruising, The car seems to be performing really well. Temperatures are okay. Hull's perfectly fine.
What we're going to do today is go run another step up in severity for our usage cases, like we talked about yesterday on some of the other higher hills, high grades, long duration. Conditions are so severe with the grade, the weight, the temperatures, and the reason we run it is because it's kind of a final check to quantify how good or how robust our cooling systems are. We take the vehicles out, we run them in real-world conditions, we capture everything we can possibly think of to help correlate our lab work.
We're looking good so far.
Okay, can you make it 8600 and open the EXP to around 350?
Done.
I was like hoping go,
Right there, it is right.
We got a golden data set today. We tried to push the system to the limits and see how it behaves, how the customer will actually see the vehicle behave.
We're in the middle of the desert in Arizona at a proving grounds that allows us to explore the limits of this vehicle, both on-road and off-road. We try to subject it to the harshest terrain possible so we can understand what works and what doesn't. What you might consider punishing it off-road, but we're learning, we're taking all that data in and constantly developing, making it better on-road and off-road.
You and I have very different usage patterns. The way you drive is different from me. The way you charge, most importantly, is very different from me. So we've inserted into our battery system the ability to learn and enhance the life of the pack through real-time, in situ adjustments to a variety of control parameters. It's really complex. So, what we say is we have smart batteries, which is like a massive oversimplification.
The battery management system is going to really cool those hot cells in that strenuous environment, and it's going to warm those cells up in a parked environment.
So that we can extend the life and the performance of the battery.
And then make the car better and better over time. If you think about any adventure, you're essentially pushing whatever you're taking with you to the limits. Different temperatures, different kind of shock and vibration. And what that means on our end is that when we take a little cell, we need to test it for every possible profile that you might put it through.
It can be used towing a boat in the middle of summer. The same customer during the winter may also go skiing in the negatives. My team's job is to satisfy all the use cases that this vehicle can potentially see.
They want to know that the battery is going to last them years and years, and it's going to maintain that same power that they expect from a Rivian vehicle.
We have world-class test and development facilities.
And as a result, we can push the cell and the battery a lot farther and a lot harder.
So if we really understand our cell, then when we give it to you and we put it in this pack, we absolutely know that for the worst case scenario that we tested, you'll never really get there.
Building cars that can drive on electricity is really a stepping stone.
What's important with electric energy, it enables us to gather that from the sun or from the wind or from the waves.
One of the things that blocks us shifting there is battery storage for storing electrons when the sun's not shining and the wind's not blowing. And that's something we focus a lot of energy on. We're really excited about the ability to take batteries, put them initially into a vehicle, but then plan for and design for those batteries at their end of vehicle life to connect them to a second life in various types of grid storage. To do that, you have to design the battery from the very beginning, such that the transition from a car to the grid is really easy.
We're all aware that we have to start taking care of our planet and doing whatever we can.
This has been the puzzle we as a company are trying to solve, and different people are working on different parts. We're thinking on a multi-decade basis. So things that we can drive our business to do, how can that affect the generations to come? Not letting the difficulties of the world prevent us from going after the things we dream about.